Okay, so our objective today is that we're going to learn how to write chemical formulas and names. So by the end of this period, you should be able to answer our essential question, which says, how do you write chemical formulas and names? On Friday, we looked at the 3 different types of bonds. Okay? So Alice, can you tell me at least one of them? Or all 3 of them if you know all 3 of them. And you can always look at your notes from Friday too.
Ionic bonds.
Ionic bonds, okay?
Covalent bonds.
Covalent bonds and metallic bonds. Very good. Ionic, covalent, and metallic. Who remembers what 2 types of elements do ionic bonds? Okay, so
Metals and nonmetals.
metals and nonmetals. Very good. Who remembers which 2 types of elements do covalent bonds? Yes, go ahead. Nonmetals. And then who does metallic bonds? Alex. Metals. Very good. All right. So that's what we learned on Friday. Which ones they bond? Which ones bond? Okay. And which type of bond they are. Now, who remembers why elements bond? Why do elements bond? John. Okay, they attract each other. Why are they attracted to each other? What do they want to have in order to be happy?
What?
What do they want to have in order to be happy or stable? Well, they become positive and negative. Tristan, can you help her out?
Neutral.
They want to be, no, they don't want to become true neutral. They want to become stable. Jackie. They want to have a full valence shell. So, Joanna, can you tell us again why they want to bond? Okay. Tristan, can you tell us what they need to be bond, or why they bond? Okay, that's for ionic, but any of them, why do they want to bond?
That way they can have a full electron share.
Very good. The
A
full
valence
valence shell.
electron.
The full valence shell. Very good. All right. So on Friday we saw that elements want to bond because they're unstable. Okay. Remember, unstable or stable and neutral are 2 different things. Okay. Stability, or for them to be stable, they have to have a full valence shell, be it 8 or 2 if they only have 1 energy level. Okay. So that is what they want. They want to be stable, so they have to have a full valence shell. In order to have a full valence shell, they bond. They either bond through ionic, covalent, or metallic bonding in order to basically complete their shell. Okay? And they either give or take or share electrons. So that's what we're going to look at today. We're going to look at when they do bond, they make a compound. How do we write the chemical formula of that compound? And what do we call that compound? So we're going to look at chemical formulas and names. So in order to do that, the first thing we're going to look at is we're going to look at oxidation numbers. Oxidation numbers are just basically the number of of electrons that they lose, share, or gain. And because they're losing or sharing electrons, that makes several of those atoms what we call ions. And ions are atoms that are charged, because remember, whenever we drew atoms, we drew them neutral, like their protons and their electrons were the same. But because they're not stable, even though they're neutral, they're not stable and therefore lose or gain electrons. And when they do that, they become positives or negatives. Now, oxidation numbers will only be 1, 2, 3, or 4. And they will be either positive or negative. So, once again, let me repeat. Oxidation numbers can only be 1, 2, 3, or 4, and they will either be positive or negative. So really think about that. And remember, oxidation number is how many electrons were lost, gained, or shared. And the numbers can only be 1, 2, 3, or 4. Who thinks they know why it can only be 1, 2, 3, or 4? It can never be more than that. 1, 2, 3, or 4. Sydney.
Because you'll never lose or gain more than that.
Okay, very good. And why do you not lose or gain more than that?
Because eight's not that big of a number, so you only want 8, so it's not that big of a number.
Okay. Tristan, can you repeat that or add to that?
Because if there's any more than 4, then it's going to want to gain.
Mm-hmm.
But if it has less, then it's want to give.
Okay, very good. So can you explain to us why the numbers are going to be added just 1, 2, 3, or 4?
Because you only need 8 to if you give it
Okay, very good. Alright, and that's why we're never going to have 1, 2, more than 4. Oxidation numbers will never be more than 4. Okay? Now, where are we getting the positive and negative from? So why is it positive or negative 1, 2, 3, or 4? Who thinks they know the answer to that? Yes? Because protons and electrons. So what would make the oxidation number negative? Very good. Okay, because electrons are what charge? Negative. So basically, I'm going to say it would be negative if it has more electrons than protons, because aren't electrons negative? Right? So when would it be positive? So they're negative when they have more electrons than protons, so when would it be positive? Very good, when you have more protons and electrons. So when we look at oxidation numbers, we're basically looking at 1, 2, 3, or 4, and positives or negatives. So right here, I have oxidation numbers for groups 1, 2, and then 13 through 18. Now, those are the only oxidation numbers that you will need to come up with. If you need an oxidation number or number of valence electrons for an element between group 3 and 13, I have to give that to you. And the reason I have to give that to you is because there's not a pattern for groups 3 through 13. But there is a pattern for groups 1, 2, and then 13 through 18. So, and the pattern is, remember that the valence electrons are always equal to the group number. So if we look at group 1, how many valence electrons does group 1 have? How many valence electrons? Group 1 has? 1. So, group 1 has 1 valence electron. Well, is it going to give 1 or take 7?
Give 1.
It's going to give 1. So it's giving away an electron. Because it gives away an electron and the electrons are negative, it ends up with 1 more proton than electrons, right? That's why its oxidation number is a +1. So it gave 1 negative away, so it becomes a +1.
So if you give away a negative, it's a positive. If you give away a positive, it's negative.
Yes. And the reason for it is because if you're giving away an electron, a negative charge, then, and you're not giving any positives away, you end up with more positives than negatives. That's what you become that's positive. And I know that sometimes students have an issue with that. Think about it this way. Okay? When you get rid of debt, don't you become more positive? Yeah. If I owe $400, that's 400 in the hole. That's a negative number, negative 400, right? And I owe it to Vanessa, and Vanessa's so nice that she says, you know what? Don't worry about it. You don't have to pay those. I really doubt she would say that to me, but okay. She said, don't worry about it. You don't have to pay me $400. So she forgave my debt of $400. So she didn't give me $400, but now I don't have to pay it. So now my debt is 0. Isn't 0 a more positive number than negative 400? Yes. So when you get rid of negative, you become more positive, right? So if you get rid of debt, you're becoming more positive. So with the electrons, because the electrons are negative, you get rid of them, you become positive, right? So here, I got rid of 1 electron, so that's just +1. In group 2, you get rid of 2 electrons, so it's a positive 2. Group 13, I got rid of 3, so it's a positive 3. Now group 14, you have 4. Well, they could give it or they could take it. So 4, it's a plus or negative 4. It just kind of depends. Okay? Now 15. How many valence electrons does 15 have?
5.
5. So is it going to give 5 or is it going to take 3?
Take 3.
It's going to take 3. So it's getting 3 electrons. Because it's getting 3 electrons and the electrons are negative, that's why it's a negative 3. 16 is going to take 2. I'm taking 2 electrons, so it's going to be a negative 2. 17, I'm taking 1, so it's going to be a negative 1. Why is 18 0?
Because they all have a balance on
They're
the
stable.
shell.
They're stable. Okay? Because they're stable, they don't need to give, they don't need to take. Therefore, it becomes a 0. Now, any questions on where you're coming up with these positives and negatives?
So it'll always be like that?
It will always be that one, yes. Now, my thing is, or what students usually do is, like, oh, I gotta memorize all those numbers. No, you don't. Because the periodic table tells you the number of valence electrons, right? 1 is 1, 2 is 2, 13 is 3, 14 is 4, and so on. Correct? So, all you really need to do is you really need to think about it. If I'm losing 1, I'm positive 1. If I'm gaining 1, I'm negative 1. So you just need to remember, when you gain electrons, since the electrons are negative, you become negative. When you lose electrons, since you're losing negatives, you become positive. Now, that tends to mess up several students just because you're thinking, wait a minute, wait. So I lose something and I'm positive? Think about it as, well, I'm losing debt. Yeah, I'm going to be positive. If I'm losing amounts that I have to pay back, I'm positive. All right? That is what messes students up the most. So that's what you really need to make sure that you work on. Remember, when I lose electrons, I become positive because now I have more protons than electrons. When I gain electrons, I become negative because now I have more negatives than positives, more electrons than protons. Okay? So, take about a minute and a half to talk to your partner, and we'll do a group of 3 right here. Talk to your partner over this section. I'm passing out 2 sticky notes. We're going to have 4 generalizations, so make sure you only use half of it. Okay, so I want everybody talking. Talk. Come up with a good generalization for this section of the notes. Oh, you can probably sit here with Orlando and do it with him. And then Jackie, you can sit with Milo. Yeah, cut it in half. Cut it or fold it in half, just separate it. It's up to you if you want to cut them. Some people do, some people don't. I should give you 2. If I didn't give you 2, call me back. So as soon as you talk about it, then take about a minute or so to write your generalization. Have about 30 more seconds to write your generalization, and we'll move on. Okay, so the reason we're talking about these oxidation numbers is because you're going to use oxidation numbers in order to write your formulas, especially if we're writing formulas for ionic bonds. So that's what we're going to look at now. Basically, writing ionic bonds it's basically a step-by-step process. So, for ionic bonds, you're going to write the symbol for the positive ion first, and then you're going to write the symbol for the negative ion. Now, remember the positive ion is the element that is losing electrons because it's losing negatives, so it becomes positive. And the negative ion is the element that is gaining electrons. It's gaining electrons, so it's gaining negative charge, it becomes negative. Now, in ionic bonds occur between what two types of elements?
Wait, it's an element like
Non-metal and metal.
element.
Non-metal and metal. Okay? Non-metal and metal. So metals and non-metals.
It's the element gaining an element losing the answer. I mean
Yeah, positive and negative. Now, metals. Are metals going to lose electrons or gain electrons? Remember, metals are groups 1, 2, and 13. So are they losing or are they gaining?
Losing.
They're losing, right? Group 1 has 1 valence electron, is going to lose it. Group 2 has 2, is going to lose it. So, those that lose electrons become positive, correct? So the positive ion usually is which element? The metal or the non-metal? The metal. So the positive ion, for the most part, is the metal element. And the negative ion is the element that gains electrons, meaning that they're in groups basically 15, 16, and 17. Those elements are the non-metals. So basically your positive ion is usually the metal, and your negative ion is usually your non-metal. Okay? So when we're writing formulas, we're going to write the positive ion, so the metal, and the negative ion second, and that's the non-metal. And then we're going to add subscripts. Who remembers what subscripts are? Sid.
it's like a little tiny two, like at the bottom, thing.
Okay, very good. So Mario, can you tell us what the subscripts are? Sydney, can you repeat your answer?
It's like a tiny number at the bottom of that. Or the
Okay, so what are the subscripts? Okay. Now, who can tell me what the subscripts tell you? What are those numbers telling you? Joanna.
How many elements are there?
Now, how many elements?
How many of that element?
Very good, okay. So how many of that element there are, right? So Eric, can you tell us what the subscript tells us?
How many number of atoms or whatever it is.
Okay. So, Vanessa, can you tell us what a subscript is? Or what is it telling us? Eric, can you repeat that?
How many atoms of whatever it is.
Okay. Of whatever it is, of whatever element it is. Okay? So like H2, what is that 2 telling you? There's 2 hydrogens, right? So you're going to start adding some subscripts to tell you how many atoms you need. And the reason you need to add subscripts is to make oxidation number 0. So we're going to do an example with calcium and chlorine. Okay? And actually we're going to do several, so you can kind of get your point. So the symbol for calcium is Ca.
Do you ready?
Well, yeah, it sounds. I'm doing a different one just because I don't want it written for every single class. So Ca, calcium is Ca, right? That goes first because calcium calcium is my metal. I know it's in group 2, so I know it's going to lose. Then chlorine. Chlorine is Cl, so that I'm going to write that second. Chlorine is going to be my negative ion because I know it's going to gain, and it's going to have to gain 1. So, my oxidation number for calcium. Calcium is in group 2. So if it's in group 2, it's going to lose 2 electrons. So it's going to become a positive 2. Chlorine is in group 17, which means it's going to gain 1 electron. So it's going to be a negative 1.
Why is it getting, why is it getting?
Because it has 7 valence electrons. It's easier to gain 1 than lose 7. Right? Chlorine has 7 valence electrons. It wants 8. It's easier to gain 1 than lose 7. Okay? That's why it gains. Alright? So, this is your first, basically your first and second step. You write the symbols, and you're going to write your oxidation numbers. Now, what you want to do is you want to make sure that these oxidation numbers cancel each other out and make 0. Well, positive 2 and negative 1 gives me 1, a positive 1. That's not 0. I want 0. So, what if I add another chlorine in there? If I add another chlorine in there, the oxidation number is still negative 1, right? So now do they equal 0?
Yes.
Yes. So, I have to add subscripts. So if I have a Ca, how many CAs do I have? 1. So do I need to put a 1 there?
No.
No. You can if you want to, or you can leave it blank. And then Cl. How many Cls do I have?
2.
And that's your chemical formula for calcium and chlorine. Okay? 1 Ca, 2 Cls. Now, that's a long one, especially when you get into one that I'm about to show you. Let's say you have this. You did this plus 2 Cl. You want to see a shortcut? You will cross this number over to this side, Cl2. And you will cross this number over to this side, Cl1.
I don't get it.
Okay?
Oh, I get it.
Now,
I got it.
let me see the other side.
That always works?
Pretty much, except for, and I'll give you the exception in a second. So let's do another one. Let's do calcium and nitrogen. So we're going to do calcium and nitrogen. So the symbol for calcium is Ca, and the symbol for nitrogen is N. What is the oxidation number of calcium? It's in group 2, so it has an oxidation number what? You're right, positive 2. Okay, nitrogen is in group 15, so what's the oxidation number of nitrogen? Negative. I'm going to do it the long way first. These two, remember, have to cancel each other out, correct? That's make 0. Do they make 0 right now?
No.
Now, I can't take anything away. I can only put more in of the same thing. So, if I put another calcium in there, now do they cancel each other out?
No.
No, I have 4 and 3, right? So, what if I put another nitrogen in there? Do they cancel each other out? No. Got 4 and 6. So now put another calcium. Do I have 6 and 6?
Yes.
So now how many calciums do I have?
3.
And how many nitrogens? Now, watch if I do the crisscross method. So, N2, oops, that's good. CA3. So if you crisscross it, it works. Now, it works most of the time. Let me show you a exception. So let's do calcium, it's gonna be several elements, it's just, but you'll see why it's in the, why it's the exception. It's gonna be obvious, okay? Alright, calcium is Ca, and what's the oxidation number of calcium? Oxygen is in group 16, what's the oxidation number of group 16?
-2.
Okay, what is the whole point of these oxidation numbers to equal what?
0.
To equal 0. Positive 2, negative 2, did they already equal 0?
Yeah. So it's just,
So it's just CaO.
oh.
So here, you don't have to cross them, they already equal 0. If they already equal 0, then you don't have to cross anything, it's just 1 to 1. Okay? So, when you do these, if you see that these two numbers are the same and they're already equal 0, you're not going to add anything anymore, you're not going to crisscross, it's just 1 to 1. Okay? Question?
I think everyone here already knows this, but, so you don't put subtract 2, like in crisscrossing?
Like at the bottom?
Yeah.
Yeah, you don't put the symbol, so you're just putting the subscript.
Okay.
Because this is telling you electrons.
I'm still learning that.
Yeah. No, and that's good, because several people do say do that. Alright? These oxidation numbers are losing, gaining electrons. Okay, that's what it's showing you. That's why it has a symbol, because you're talking about the electrons. These, at the bottom, do not have a positive or negative, because these are telling you how many you have. You can't have negative amount. Okay? So the bottom numbers don't have positives and negatives, because you're telling me how many you have. Like, I have 3. I don't have negative 3. I have 3 calciums. I have 2 nitrogens. That's what those numbers are showing. Okay? Yes. Bless you.
That's the only time that it's an exception when the both equal 0.
Yes. That would be the only time that you don't use the crisscross method. If both of them are the same, then don't do crisscross. It's just a 1-to-1 ratio. Okay? Any questions over those? Okay. So, take about a minute and a half, talk to your partner, and come up with your second generalization for your notes.
The oxidation is
So come up with your second generalization for this section. I should hear some talking. Some of you are not talking to the person beside you. That's why they're there. To help you out, you should be talking to your partner.
Which one? 2 number? I'll think about the valve.
We live in the poor area, we live in Tent City, so everybody goes to the rich area.
I'm getting a phone call. I'll go.
At the city, like 15 minutes from Galveston.
My birthday's coming up. Yeah, that's someone's birthday. And for Christmas, my birthday, I'm getting a
Okay. So, moving on, our next section. So you need to have the ability to write a chemical formula for 2 elements. And after you write the chemical formula for those 2 elements, you should be able to name them. So actual name form. Same thing, you have a specific way to do it. You write the name of the first element, so you're going to write the name of your metal, because it's for ionic bonds. Then you're going to write the root name of your second element. The root name is just the main part of the word. You're going to basically drop off the last part of the word, and you're going to add I-D-E. So, we're going to do the sample NaCl. And we're going to do another one. Okay, so NaCl. Na is basically sodium. So that's your first one, so you just write it exactly like it is on the periodic table. Now,
Wait, do we write sodium?
yes, I'm showing you the example. Now guys, I just said exactly like it says on the periodic table, which means I should not see any misspelling with this first word. You might have a little issue with the second one, but definitely not the first one, because that's just copying off the periodic table. If you copy it wrong, it will be counted wrong. And you're going to say, oh, man, but they're hard words. Not if you're copying off the periodic table. Now, if I sit here and I say, okay, guys, I need everybody to write zirconium, and I want you to write it correctly. Without you looking, then that's kind of messed up. Or if I go and I say, okay, write uninium. Okay? So, that would be a little messed up. But if I'm telling you, use the periodic table and copy it off of the periodic table, then you should not be misspelling it. It's copying. So, if you don't want to take the time to copy it right, then it's going to be wrong. So, make sure that you spell it incorrectly. How do you make sure? Look at the periodic table. Okay? So, you write the first name of the first element. Then, the second element is chlorine. You're going to only write the root. The root for chlorine is chlor. And then, instead of ene, I-N-E, you're going to add the ending I-D-E. So NaCl, the name for NaCl is sodium chloride. That's what it's called. Okay? So, let's do one more. Let's do the one that you just came up with. You had calcium and chlorine. We said that was CaCl2, right? So, to write that, I'm going to write the name of the first element, and the first element is what?
Calcium.
Calcium. And then I'm going to write the root word for chlorine, which is
Chlor.
chlor. And then I'm going to add ID. So CaCl2 is calcium chloride.
It doesn't matter about the substitute.
Yeah. And for ionic bonding, it doesn't matter. For covalent, it will. Okay? So that's a good question. Sydney just said, so that 2 doesn't matter. For ionic bonding, it doesn't matter. For covalent bonding, it does. So how are you going to be able to know which one is which?
Caring and sharing.
Sharing is caring.
Well, caring and sharing, yes. But let's say if I just give you this. How would you know on a test if I give you this? How would you know that this is ionic instead of covalent?
Because like covalent, they share. So like it would be in the middle of them.
But this is not a Lewis dot diagram, so I'm going to show you that. Yes?
Because there are 2 chlorine atoms, and then they are both. Oh, why not?
This is ionic, it's not
I
covalent.
know.
Wait, what's the question?
How would you know that CaCl2 is ionic but not covalent? Alex?
Because it's no metal in the middle.
Very good.
Oh yeah, good job, Alex.
Very good. You would know, if I gave this to you on the test, you know that this is ionic because it's a metal and a non-metal. If you see a metal and a non-metal, it's ionic. So these are the rules that you need to use. Okay? Now, go ahead and write a generalization for this section of the notes. So take about a minute and a half, and I want you to discuss. I want to hear some talking, guys. Talk about what your generalization can be before you write it down. Remember, you want a complete generalization where you're covering the entire note. Talk about it before you write it down. Make sure it's a good generalization.
Write the element.
You have about 30 seconds to finish up your generalization. Okay, so now let's move on to our next one. Now we're going to talk about covalent bonds. Now with covalent bonds, you will not have to write a chemical formula for a covalent bond. I will either give you the formula or the name. If I give you the formula, you have to come up with the name. If I give you the name, you have to come up with the formula. But you won't have to write a covalent bond just from looking at the periodic table. So, with names for covalent bonds. In this case, now you have to look at the subscripts and how many there are. And when you do so, you're going to come up with some prefixes. So when you name covalent bonds, you're going to write the name of the first element with its appropriate prefix. So if there's one, you don't have to worry about it for the first one. If there's two, you say di. If there's three, that's a tri, and move on. Then you're going to write the appropriate, for the second element, you write the appropriate prefix for the second element. Not in this case. It can be. Di or bi or both between the two, but the way it's used here, you always use di. So for the second element, you write the appropriate prefix, you write the root name, and you end with I. So with the second element, it's sort of the same as with ionic bonding, except for the fact that you're adding a prefix to it. These are the prefixes that you're going to use. One is mono. You only use mono for the second element. So if your first element only has one to it, you don't write the word mono, you just write the element. So like for example, carbon dioxide, CO2. There's only one carbon. You're not going to put mono carbon dioxide. It's just carbon dioxide. So you only use the prefix mono for the second element. But everything else you do. So 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 hexa, 7 hepta, 8 octa, 9 nona.
I thought we were only going up to
10
4.
deca. Not in this case. You're thinking oxidation numbers. We're talking about subscripts. Right? Now, most of these, you already know. or you've heard at one point in time or another. Okay? For mono, maybe you've heard it, maybe you haven't. Di, you've heard. Guys, whenever you get some dies, those usually have two.
Oh
You
yeah.
have two die. Okay? Tricycle, 3. Tetris had 4 little boxes in it.
What's a Tetris?
You never played Tetris?
No.
Oh.
Yeah. Where you
That's
move
how-
around
that's
the
how
little-
I-
the one with the
What
little
is
dots
it?
on the-
It's those little blocks that come down and there's like lines or there's L's or
And you have
there's
to fit
a
it in.
Or
square.
ladder or something, right? The ladders.
No, like the little, like the little.
Oh, I know. A yellow
Yeah.
thing is the
Have you never seen it nowhere?
And then you hit the thing and then like the dice and then you like go how many
No, it's a computer, it's a video game.
You can flip in there.
That's video.
Oh, yeah.
Oh, it's actually wasn't a video game, it's a phone game. Alright, so 4 tetra, 5 penta, that one you might have heard before. 6 hexa, you might have heard that one before. 7 hepta, probably not. 8 octa, you've heard that before. 9 nona, 10 deca. You've heard this one before. Decade, 10 years. Deca, 10. That's where deca came from. Right? So, you might look at these and like, oh my goodness, I'm gonna have to remember all those. Guys, some of these you already know. Actually, most of them you've probably heard before in another word. So kind of whenever you're looking at these, just think about other words that you know with prefixes like
Nona?
this.
Nona? Like how would you remember that?
One
You're
more.
gonna have to figure it out. Okay?
Like
So,
9,
y'all need to make sure that you know these. Because I could give you something like this that you're gonna have to name.
Is it like
N2O5 is a covalent bond.
because it's all non-metal.
Yep. And you know it because N is a non-metal, O is a non-metal. That's how you're gonna figure it
How
out.
many people?
Okay? This is it. This last. N2O5. So looking at that, the first part of writing the names is you look at your first element. The first element is nitrogen, but it does have a subscription to 2. So what's the prefix for 2?
Di.
Di.
Nitro
So
di.
you're going to put di and then nitrogen.
Oh, you put that.
It's a prefix. It's always first. Pre means first. So dinitrogen. And then I have O, which is oxygen. I have to put the prefix first. So what's the prefix for 5? Penta.
Pentagon. That has five sides.
So, yep. Penta. I write my root name, which is ox. And then I end with ID. So N2O5 is dinitrogen pentaoxide. Okay? So you follow the same ones. So let's look at another one. What is that?
Water.
That's water, right? Everybody knows that's water. There's a chemical name for it. So, what would I do first?
High. Di. High.
So, dihydrogen. Okay. How many oxygens do I have? One. So, mono. Mono what? Dihydrogen. Yes. So, dihydrogen monoxide. Now, I'm just going to add this just because I think it's funny. Okay? Some students, some college town or whatever, went around asking people, hey, it's like, do you know that they put dihydrogen monoxide in the water that you're drinking every day? You know that that's in there? And they're looking like, what? What do you mean? It's like, yeah, you know, it's in some instances it can kill you. Like you can drown because of it. Well, you can drown with it. It's water. Okay. Oh, do you know that it has a bunch of chemicals that could basically hurt you? It's like, so did you know that they put that in the water system? You drink that every day. And they're like, oh my was like, so you start getting all, well, they just told you they put water in water. Okay, that is water. So just because a word looks scary, it's not scary. This is water,
I might somebody.
okay? That's water. It's just most people don't know the chemical name for water, and that's the chemical name for water. Okay? So, any questions on that? All right, go ahead and write your last generalization for the section at the end of the notes.
Because I don't know who write.
And